Alright guys, welcome back to Precalculus, Chapter 7, Section 1, where we spent Chapter 5 and Chapter 6 solving right triangles and all the properties of right triangles. We're going to spend Chapter 7 dealing with non-right triangles. So the first thing we're going to deal with is the law of sines. Probably the easiest one to use. You can see it right here. It's got two different forms. Sine of an angle over the side across from it is equal to the sine of another angle over the side across from that. Okay, and that's pretty much all you need to know, and you can flip it otherwise, and you can use it interchangeably between whatever information you happen to have within your triangles. The important thing to understand is that the law of sines is only going to be possible for angle-side angle triangles, angle-angle-side triangles, and side-side angle triangles. And we'll put a star over here because that's going to be a special case for us that we're going to have to remember coming down the road. But anyways, let's jump right into using the law of sines here for a quick example. We see we have a triangle. It's just not labeled, so let's go ahead and just label it ABC. Doesn't really matter what the letters are. But you can see that it is an angle side-side triangle. I told you that's a special case, but we're just going to ignore that for now and apply the law of sines. Okay, so if I know that the sine of 82 degrees over 29 is equal to the sine of angle B over 20. Okay, that's just using the law of sines up here. I know that I have the side across from B, so I'm going to solve for the angle that I don't know. Okay, if I tried to solve for angle C, I wouldn't be able to because I don't know the side across from it. Okay, so a little cross multiplication can get me to 20 sine of 82 degrees is equal to 29 sine B. And then I just got to divide by 29. Both sides, and I'll end up with the sine of B is equal to, and I'm going to go ahead and switch over to my calculator here and just make sure that I'm in degree mode. Right now it's still in radians from chapter 5 and 6. I'm going to go into degree mode, and I'm going to do 20 sine of 82. Now I'm going to hit enter, and then I'm going to divide by 29 and hit enter, and I'm going to get 0.682 yada yada yada. So 0.682. If we recall, in order for me to figure out what B is, I'm going to have to take the arc sine of both sides. So B is equal to the arc sine of 0.682. So we can go back to our calculator really quick, take the arc sine of our previous answer, hit enter, and I get 43.07 degrees for angle B. So that means this angle is 43.07 degrees, and a little 180 minus 82 minus 43.07. We can do that on our calculator if you would like. 180 minus 82 minus 43.07 will give me my third angle, which is 54.93 degrees. Okay, so down here at the bottom, what you're seeing is a little bit of what we call the ambiguous case. It's dealing with those side-side angle triangles that we told you were a catch-22. So what I'm going to do is, rather than teaching this all the way through here, I'm just going to let you have this to reference. You can read through it on your own. You can reference it whenever you get a side-side angle triangle, and rebuff yourself. But we're going to teach it through an example. So what we're going to do here is we are going to change our examples to this one right here. So let's take it angle A, angle B, angle C, and let's just make this triangle with a 63 degree, a side length 8, and a side length 6. So while you're drawing that, I'm going to point out that it is an angle side-side, or if you want to review it, side-side angle, okay? Either way, kind of spells a bad word, so you know something's fishy, okay? Now, here's what's fishy about this. If I go through this right now and try to, the only angle I can find is C. I can't find B because I don't know the side across from it. So if I try to find angle C, so I go sine C over 8 equals sine 63 over 6. So that means a little cross multiplication. I'm going to do 8 times sine 63 divided by 6, and I'm going to take the arc sine of it. And we're going to see something happen here in the calculator right now as I do that. So if I take the arc sine of 8 sine 63 divided by 6, oops, it's going to yell at me and say I got an error, because it is impossible for this triangle to exist. And you can see that by looking at this diagram here. Okay, if we look at this diagram here, we see that if we have a 63-degree angle and a side length 8, that the height of this triangle happens to be 7.13, and my side length 6 is never going to complete the triangle. So in fact, when we have this triangle that's drawn right here, that this space right here is actually missing, and there's a hole in our triangle. Okay, so this triangle is impossible. So the bottom line is that if this side length right here, this 6 across from the angle given, is smaller than this height, which is 7.13, then it's always going to be impossible, because you're always going to result in a triangle that has a hole in it. Okay, so bottom line is you're done. You're done for now, okay, with that type of problem. Now you're probably asking, well, how do I know what the height is so I can know if my, quote unquote swinging side here is smaller than it? Well, it's really simple. You treat this as a right triangle, because it is. To solve for height, you could simply say the sine of 63, by definition, in a right triangle, is opposite over hypotenuse, h over 8. And if you multiply the 8 over, you would get h equals 7.13. I'm not going to do that on my calculator right now, but you can check it. Okay, so that's what all this information was saying on the front. Okay, so was telling you when a triangle is impossible, and now it's going to tell you also when it's possible. Okay, because it is possible if this 6 is a little bit bigger. So if the 6 happens to be bigger than both 7.13 and 8, then you're going to have one triangle, and you're going to solve it very similar to how we solved for this triangle right here. Just doing the law of sines and working your way through it. Okay? But if you choose a value that is between 7.13 and 8, that's where you're actually going to get two triangles, and I'll show you right now. So if we choose a value, maybe we choose 7.5. Okay, you can look at it now and you can see like, oh, okay, I can complete my triangle here. I've got a nice big wide triangle, and then I can complete my triangle right there, and I've got this small sliver of a triangle. Beautiful. So that's what we're going to actually end up with. So we're going to change this 6 to 7.5 now. And we're going to solve for both triangles. So we're going to make it now possible. Okay? So what we see here, going back to my diagram, see we have a big triangle like I just drew, 63, 8, 7.5. That's this. And if I swing my swinging side through, okay, I get a smaller obtuse triangle. Okay, having a little bit of trouble lining it up, but nevertheless, you understand. So I'm going to go ahead and draw that. Notice the 63 is still the same, the 8 is still the same, and the 7.5 is still the same. But both these triangles are possible given a 63, 8, 7.5. So all we have to do is do the law of sines. So now let's go through and let's do the law of sines to find angle C. Okay, so rather than having a 6 right here, it's going to be the same process. Sine C over 8 is going to be equal to sine 63 over 7.5. So all I got to do is go back to my calculator and change the 6 to a 7.5. And let's see what we get here. 71.9. We'll call it 71.9 for the sake of our argument here. So angle C equals 71.9 degrees in this triangle. So what I'm going to do here is go back to my diagram, and you can even see it on my diagram. This angle right here at the bottom right is 71.9 degrees. Okay. The cool thing about it is, if you look at this triangle that's in the middle of the diagram here, where the height is kind of splitting it, we're not actually drawing that triangle by any means, but that triangle is an isosceles triangle. Okay, meaning the two base angles are the same. So if this is 71.9, that means this has to be 71.9. Okay, the angle on the bottom left of that isosceles triangle, which means that its supplementary angle, which happens to also be this angle where my pen is going to be 180 minus 71.9. Okay, so what is that? 180 minus 70 is 110, 109, 108.1 degrees. Okay, so now that we know two angles in this triangle, we know two angles in this triangle, we can find a third angle. So in the top angle, or the top triangle, it's going to be 180 minus 63 minus 71.9. We hit enter, and our angle B in the top triangle is, forget what I had there, 45.1. And if we do 180 minus 63, type it out here, minus 108.1, we're going to get the angle B 8.9 degrees. This one right here is 8.9 degrees. So we've got all the angles on both triangles. Now it's just a matter of solving for side B in each triangle, and we're just going to be using the law of sines to do that as well. The law of sines is typically very easy to use, so we know that in our top triangle B was 45.1, so sine of 45.1 over side B is equal to sine of 63 over 7.5. Okay, so just a little cross multiplication, 7.5 times sine of 45.1, and then I'm going to divide by sine of 63, and it'll give me B. Clear my screen. So we've got 7.5 sine of 45.1 divided by the sine of 63. I'll hit enter, and my B is 5.96 for my top triangle here. I could do a little bit better job of organizing my data, but 5.96. And it's going to be the same exact process for finding side length B in my smaller obtuse triangle here, okay? Except now it's going to be sine of 8.9 over side B is going to be equal to sine of 63 over 7.5. So the only thing that's changing is where I had 45.1 is now going to say 8.9. So I'm going to go back to my calculator, grab the same entry, and instead of where it says 45.1, I'm going to change it to say 8.9, and hit enter, and I get 1.3. So B in my bottom triangle is length 1.3. That's all for now. We'll revisit this one in class or in meeting time. It is going to be a question in your homework and something that you're going to have to do, so I'm going to suggest that you do attempt to find the answer to this question on your own. Thank you very much.